All right, are you ready for P.5? Because this is where we're going to be learning how to do what we just did in P.4 but going backwards. So an important part of higher mathematics is being able to factor polynomials. Factoring a polynomial is going backwards of what we were doing with multiplying polynomials, aka foiling. So basically we are undoing FOIL in most cases. Just like factoring numbers, we can break down polynomials into products. So for example, if I wanted to factor the number, just a second. Okay, if I wanted to factor the number 15, this is just a number, so I could break it down as 5.3 or 5 times 3. I could also look at factors of 15 to be 1 times 15. Those we can break up into individual pieces, but when we have a polynomial, for instance, x squared minus 4, and when we want to look at the factors of that, that would mean we would have to figure out what do we multiply by each other, or in some cases by itself, to create this x squared minus 4. Okay, so if we were to investigate what we just did prior in P.4, this was what we referred to as the difference of squares, in which if I were to multiply and do the first outer inner last of this, I would end up with this x squared minus 4. But we don't want to start here always and multiply straight through. Sometimes we have to start here and come back to these factors. So what we want to look at is polynomials that cannot be factored using integers are also called prime polynomials. So we have prime numbers, like the number 3 is prime, the number 7 is prime, 11. We also have prime polynomials that do not factor down. But in order for a polynomial to be factored completely, all the way down, factored completely, then the polynomial is a product of factors which are prime. So basically you just kind of keep going down and ask yourself, can I go further? Can I go further? Okay? And we will do that throughout. Now, the first rule of factoring, though, is to take out any common terms. So we will look at any polynomial and say, first, is there anything I can take out first that's common to all to make it a little bit more simplistic? And that's kind of our first rule of factoring. So in order to take out the common terms, we must determine the greatest common factor of each of the monomials. Okay, so when I talk about monomials, I'm looking at each of these terms, okay? Of each of the terms, what is common to both? Now you got to look at your numbers and you have to look at your letters. So if I look at this first one and I say, okay, what is common to each one of these? Well, with 16 and 24, thinking of the factors, the greatest common factor with each one of those is an 8. I also see that there is an x in the first term, but not an x in the second term, so there are no variables that are common to each. So in this case, the only thing that I have common to each of those terms is an 8. So what I want to do, we can also kind of write that up here if we want, GCF is 8. I need to now figure out what did I have to multiply by that 8 in order to get that 16x and 24. So in this case, we're kind of undoing the distributive property, kind of going backwards of what we normally do. So I always ask myself, 8 times what gives me a 16x? Well, I need a 2 to make the 16, and I need to just tag that x on because when I multiply 8 times 2x, I do get 16x minus 8 times what number here will give me that 24? Well, 8 times 3 is 24. So this would be completely factored, and you can always check your answer by distributing that through. Take the 8 times the 2x and take the 8 times the 3, and you can tell whether or not you get back what you started with. And that's what we want. So it's a nice, easy way to check things out. All right, if we look at the next one, 8x cubed and 4x squared. Look at your numbers. What is the highest number that will go into each one of those? Well, hopefully you say 4. 2 will go into both of those, but 4 was the highest one that will go into each one of those. Now, each of them this time have an x. One is an x cubed and one is an x squared. So we have to know what does each of them both have. One has 3, one has 2. They both have at least 2. So that's why I'm going to take out the lowest power always. Of any common variable, the lowest power has to come out. So that's the only two things that I have to consider in this one. And now I have to determine what's left over. So what do I multiply 4 by to get an 8? Well, it is a 2. I have 2 x's here. I need 3 x's, so that means I need one more inside. So if I multiply this times this, I do get my 8x cubed. Minus, now, what do I multiply 4 by to get 4 back? Well, you should hopefully tell me 1. And I have both x's here, which would happen here. Okay, so there's nothing else but 1. I took everything out basically on the common factor. And so if everything back here is the common factor, you have to have kind of a placeholder of a 1, if you want to think of it that way. But you just can't drop this off. A lot of times I'll have some kids that will give me this because they think, well, there's nothing left there. Well, if you just multiply this and this, you're only going to get one term. You're not going to get 2 terms here. So remember, double check by taking this times this and this times this to make sure that you have the final answer. Okay? All right, let's try this next one. This next one, we have a 2 and a 6. So hopefully you say that the common number that will go evenly into both of those is a 2. And we have an x cubed and an x to the 5th. Well, the least power here is the x cubed. So we want to take out the 2 and the x cubed, but notice we have this negative in front. Most of the time we don't like to have a negative in front, so this is an exercise in me showing you how to take a negative out of 2 terms. So when I do that, I have to now come back and figure out what do I multiply this term by to get this back. Well, here's the negative 2 with that. I have 3 x's out front. I need 5, so that means I have 2 that are left over inside. Now, what do I multiply this by to get this back? Well, obviously, if I take a negative 2 away from there, and in a sense what we're doing is dividing to figure out what's left over. Positive 6 divided by negative 2 should be a negative 3. Anytime you take out a negative, this sign will change and that sign will change inside here. All right, so I have 3 x's here. I pulled 3 x's out front, so hopefully when I take this times this, I do get that first term, and this times this does give me my second term, so I have taken out the greatest common factor to both of those. Okay? All right, and our last one here is an exercise in which we don't just have a variable in common, we actually have an expression in common. So between 2 terms, here's one term separated by a plus or a minus. There's my second term. Now I need to figure out, okay, what do I need to multiply, or what is in common, sorry, for both of these terms that I can pull out front. So notice that there's not a number in common. This has an x, but this one doesn't have an x by itself. This has an x minus 7, and that has an x minus 7 that is common. So that is actually what I'm going to pull out front, and now I have to determine what's left over. So x minus 7 times what gives me this? Well, hopefully you realize that that's already taken up. We just need that 2x. And for the second term, I already have the x minus 7 out front, so what's left over is this plus 3. So hopefully you'll get used to basically the leftover is what's going to happen in front of the parentheses, 2x plus 3 when I take that x minus 7 out. So this is actually my final answer. Okay, and that's going to help us in different factorings later on when we get to the next part, which is what happens if I end up having a 4-term polynomial that I need to factor. And we're going to, anytime you are factoring, I want you to be conscious of how many terms that you have. And this note sheet will kind of help you by determining how many factors. There I have 4 terms, here I have 2 terms, and so it's going to kind of lead you to how to factor that problem, the process that you need to use. Okay, so let's look at 4 terms. We're going to do this by what we call grouping. Now there's multiple groupings, couple of groupings. Normally we will do a 2 by 2, but I will tell you there are some 3 by 1s and 1 by 3s that you can do grouping, but mostly we're going to do 2 by 2s. So when factoring, it's good for you to determine how many terms are in the polynomial. This will drive the method you will need to use in order to factor the polynomial. With 4-term polynomials, one will need to group 2 by 2, meaning grouping 2 terms together and the other 2 terms together. Once you have grouped up, one will need to take out the greatest common factor of each group separately, just like what we were doing in the previous examples. So in this first example, I'm going to choose these 2 terms to group up separately into 2 separate groups. And when you group things, there should be things that are in common. If you do not have things that are in common, then you need to go back and put 2 other terms together in order for that to happen. So if I just look at these first 2 terms here, notice there's not a number, well, there is an invisible one, but not a number that we could pull out that's common to both except for 1, which isn't going to change anything. But this one has an x squared, this one has x cubed. So I'm hoping that you tell me they each have at least an x squared. That will be the only greatest common factor that I can pull out. Now, what do we have that's left over? X squared times what is x cubed? I hope you tell me x. Minus x squared times what gives me a 3x squared? Well, I'm hoping that you realize that 3 is the only thing that's left over. So hopefully, in this type of problem, we're wanting this expression to be what's in common. So out of these 2 terms here, I'm hoping to get this x minus 3 in this set of parentheses. So if I look at 4x and 12, this is a positive 4, that's a minus 12. There is a 4 in common, but notice there's not an x in this term, so there wouldn't be any variables. So I'm going to take out a positive 4. Now notice I put that plus there to separate my first term here with my second one. If you end up taking out a negative, this would be a minus. All right, so 4 times what is 4x? Hoping you say x. Positive 4 times a negative what gives me a negative 12? Well, 4 times a negative 3 gives me a negative 12. So you can go ahead and put that sign down there knowing that you're not taking a negative out to change. And then just ask yourself 4 times what number is 12. That might be easier. So I'm hoping you realize or see now with these 2 terms that there is an expression that's in common. So looking here and looking here, the x minus 3 is in common with both. So I'm going to take that out in order for it to be completely factored. And what I have left over, remember, ends up being the terms that are in front of those parentheses. So an x squared plus 4 would be my answer. Now, we would have to double check. Can I go further with this? Can I go any further down with this? And if you have a power of 1 here, the answer will be no. If you have something other than a power of 1, this might be able to come back down a little bit more. So you want to watch that. This one right now actually does not. So this will be our final answer. And we'll see some in a few minutes of those that will go down a little bit further. All right, let's try this other 4-term polynomial. If you want to turn this video off and try this one on your own, that would be okay too, to see how well that you can do that. And then play the video to see if you get it right. So for these 2 terms, I'm going to group the first 2 and the second 2 together. Notice between x cubed and a 5x squared, no numbers in common just like last time, but there is an x squared in common. Then I'm going to take out an x squared, leaving me with an x, and then I need a plus 5 in order to make this term. My pen ran out. Okay, I'm back and running. It's good when technology works. All right, so then we have that plus 5 there. On these other 2 terms, I have a negative 2 that's in common. So I'm going to pull out a negative 2. Now be very careful. If you pull out a negative, that means you got to switch the signs. This is going to become positive. That's going to become positive. So negative 2 times what is negative 2x? Hopefully you say an x. And negative 2 times what is a negative 10? That's going to become a plus 5. So this sign changed, that sign changed. That's good. All right, between this term and this term, there is a common expression of an x plus 5. And what is left over has to be these little guys out front. So we have an x squared minus a 2. And again, these 2 here won't go down further, but we always want to make sure that we check that. All right, so let's move forward. When we have a 2-termed polynomial that we need to factor, we need to think about difference of squares. Now with 2 terms, First thing you always want to do is take out common terms and then see if you have a difference of squares. Now, what do you get when you FOIL? Here's the question. A plus B times an A minus B. Well, we can try that if we want to. We can do our first term, which gives us an A squared. Outside is A minus AB. Inside is A plus AB. Notice those would cancel themselves out. And my last term here becomes a minus B squared. And that's similar to what we just had on the previous page that I started you with when breaking things down to factors. But this one is so important to know. Make sure you know this special pattern, that whenever you have two things that are exactly the same inside here, A's and B's are the same, the only difference is your plus and minus. That is our difference of squares. That is so important to know. So here's what we really want to start. A squared minus B squared will always factor into that A plus B times an A minus B. That right there, I would start that multiple times so that you commit that to memory. So let's try these. Once you get the pattern down, it becomes really, really easy. But you have to be able to work with patterns and be able to do that very nicely. So here, nothing in common between x squared and 81. I can't factor anything out that's common. No x's in common, there's no numbers in common. But I do have a difference, and I do have two terms. That these are actually perfect squares. What do I square to get an x squared? Well, it is x, because x times x is x squared. What do I square to get an 81? It is 9 times 9. So 9 is the perfect square there. So I'm going to factor this into two binomials. One's a plus, the other's a minus. I'm going to split this x squared evenly as an x and an x in the front. Then I'm going to figure out what is the square root of this, basically. What do I multiply by itself to get 81? It is a 9 and a 9, and you are finished. Once you know this pattern and can recognize the difference of squares, this goes very, very quickly. Okay, so this would be your final answer. When you were to multiply that or to FOIL it, you're going to get back x squared minus 81. So what happens when I have these guys going on? Remember, this front one is going to be our a's, and the back is going to be our b's. It's, again, a difference of two perfect squares. Again, for powers of variables, we want those to be evens for perfect squares. And what times what gives me 36? That is the same. It is a 6, so I'm going to put a 6x in the front. What do I multiply by itself to get 25? It is a 5, and I need to put a y in the back. Same way with this one. One is a plus, and the other is a minus. Doesn't matter if you put the plus first or the minus first. Just at least I have one plus and one minus, and that is it. That is your difference of squares. Now, each one of these have had a power of 1 on the variable whenever I broke them down. So once you get that, then it is prime. You are done. You can't go any further. But let's look at this one. Let's see if we can go further with the factors. So I have x to the 4th minus 81. Again, nothing in common, and that's very similar to this one, except for I have two more x's. Now, it is a difference of perfect squares. X to the 4th is a perfect square because it's an even number. And 81 is as well. So I'm going to split the x to the 4th evenly. Cut it in half, basically. X squared and x squared is going to go into each. I'm going to get a plus and a minus. And what do I square to get an 81? It is a 9 and a 9. Now, notice we don't have powers of 1 this time. I have powers of 2. So it's very likely it might go down further. Now, we have never had anything yet that I've told you about a sum of two perfect squares. So this, in terms, will never break down with our real numbers. So I'm just going to rewrite this one for the time being. Unlike this one, though, I have a difference this time. X squared is a perfect square, and I get another perfect square, which is 9. What do I square to get a 9? Hopefully you say 3. So I can actually break this one down into two binomials that will then become prime binomials. So again, if you can go further, please do so. Remember, one's a plus, one's a minus. And the fronts have to be the same and the backs have to be the same. So what do I put in front? Well, split that x squared up as an x and x. How do I break this down? Well, what do we square to get 9? It is a 3 and a 3. So now that I have powers of 1 on these each ones here, I'm down to my prime. This can't go further. If you have a sum of squares, it will never go forward. Okay? So always check to see if you can go further or not. All right, so that was a two-term polynomial as the difference of perfect squares. Now we're going to look at two-term polynomials that are the sums and differences of cubes. So think about your cubes. If you remember those, 1, 8, 27, 64, 125, 216. Those are all numbers that you need to recognize as perfect cubes. And so, if a two-term polynomial is not a difference of squares, try a sum or difference of cubes. So here's two special cases. We have a cubed plus b cubed and a cubed minus b cubed, okay? Now, these are going to be very, very similar. They're only going to be different by signs. But there is another pattern. So again, you have to make sure that you know the pattern with these and be able to work with it, okay? So this is going to be a binomial times a trinomial. So the first one's up here with sum or difference of squares. It broke down into two binomials, meaning two terms in each. And these are going to break down to a two-term and a three-term polynomial. So I'm going to do a binomial times a trinomial. Now, in order for us to deal with the signs, I want you to remember SOAP. Same, opposite, always positive, okay? So this one is going to be the same sign. This is going to be the opposite sign. And the last sign here is always positive. So if I start here, I have a plus. It's going to be the same sign. Change to the opposite, which is now a minus. And this one is always a plus. So in every single case here, you're going to have two pluses and one minus. Now, what is the pattern to break it down? You need to ask yourself, what do I cube to get an a cubed? Well, it has to be a times a times a. So I need an a here. What do I cube to get a b cubed? Well, it's b times b times b. So I have to cube b to get a b cubed. Now, the pattern is this. I'm going to square the first, multiply the two terms together, ab, and square the last term. So when I say square the first, I'm going to square the first one, multiply these two together to get the second term, and square the last to get the last term. Okay? So you can write that under there if you want. Square the first, multiply the two of them together, and square the last so that you remember that pattern as well. But this is how something like this would break down. Now, what if I do the next one here, okay? So if I have a minus, it's going to be exactly the same, okay? A binomial times a trinomial. Take care of our signs first. Let's do the same, the opposite, and always positive. So the same sign now is a minus. I start with a minus. This has to be a minus. Then I do the opposite sign, always a plus. There's my two pluses and one minus. What do I cube to get an a cubed? It's going to go out front. What do I cube to get a b cubed? It's going to go in the last term. And then we're going to do this pattern. I'm going to square the first as a squared. I'm going to multiply the two terms together to get AB, and then I'm going to square the last to become a B squared. So again, a pattern that you really, really need to know. So let's try these. Two examples. Remember SOAP for your signs and that there are only two pluses and one minuses. There we go as our reminder. And this is also a good reminder that once you factor down into the binomial times a trinomial, that trinomial will never break down. It can't go further like we just did with this problem right here. You can't go further with this the trinomial in this factoring. Okay, so once you basically go the bi times the tri, then you're done. All right, so let's try this one. I have two terms. Nothing's in common. It's not a difference of squares because I have a plus here. So we have to check this case to whether or not we have a sum or difference of cubes. This is a perfect cube because I've got three of them. And one is a perfect cube. One's a perfect anything. So yes, I am going to be able to break this into a binomial times a trinomial. Let's do our signs first. If this is a plus, this is the same. This one is opposite, and this one is always positive. So, for you to remember that. And what do I cube to get an x cubed? That's what I need to ask myself here. What do I cube to get an x cubed? It is an x. What do I do, or what do I cube to get a 1? it has to be a 1. Then I'm going to take this pattern, square the first, multiply the 2, and square the last. So I'm going to square the first to give me an x squared. I'm going to multiply this times this, so 1 times x is just x. You can put a 1 there if you want, but you don't have to. And squaring the last gives me a 1. And that right there is done. You can't go further on any of these sums or differences of cubes. Okay? All right, now we have a difference. Nothing in common between 125 and 8. You can't go further. I do have a difference, so it could be difference of squares or difference of cubes, but 125 is a perfect cube. Likewise, 8 is a perfect cube, and x cubed is a perfect cube. So at that point, I determine it's going to be a difference of cubes here, which factors into a binomial times a trinomial. And so, what do I cube? Actually, let's first take care of our signs. If this is a minus, this is the same, this one is opposite, and this one is always positive. So what do I cube to get a 125x cubed? The answer should be 5 and an x. What times what times what gives me an 8? What do I cube to get an 8? Well, I hope that you say it's a 2. So again, knowing those perfect cubes from what we did on our radical section is going to be helpful for you as well. Now, let's take this pattern. Square the first term. Now square both of them. So I got a 25 and an x squared. Multiply these two together. Who cares about the sign? Just look at the terms. 2 times 5x gives me a 10x. And square the last term. 2 times 2 is a 4. And again, that is it. Once you break down the sum or difference of cubes, you can't go further than that. Okay? All right, very good. So those are kind of our special cases, and those are the things that you need to work through before we get down to this trial and error section where we have 3-term polynomials. So everything that we did before, first taking out common terms, then looking at 4 terms, which is done by grouping, and then these 2-term special cases, there are 3. Make sure you look through each one of those first, and then we are now looking at our 3-term trinomials in order to factor those. And the best way we can do this, again, we're undoing FOIL, and the best way that I know how to teach you this, and the quickest way, is by trial and error. There are other ways that you can do it, but I have found over the years that this is the most easiest, and once kids get the hang of it, then it is the most quickest. All right, so in order to factor the trinomials, you must know the following. Trinomials will factor into 2 binomials. So it will be 2 2-term polynomials. This is going to be helpful when we talk about the signs. If the last sign is a positive, then the signs are the same that match the first. That's important. Last sign is a plus, they are the same that match the first. If the last sign is a minus, the signs are different in sign. So one's a plus and one's a minus. And the third thing I want you to remember is that you can always check your work by foiling your answer to see if it equals what you started with. That is so important in math. Sometimes we don't reiterate that enough, but it is so important to check your work. Sometimes we don't have the time to, we think, but it is so important. All right, so let's look at this first trinomial. And we're going to start off with ones that have a plus at the end. So always look at the last sign. That's going to determine the signs inside your 2 binomials. Notice there's actually nothing in common here, so I forgot to check that, but there's nothing in common. So we go directly to our 3-term strategy, which is by trial and error. So the last sign is a plus, so it is the same that matches the first inside. So if that's a plus, they are the same that match the first. So that means each one of these gets a plus and a plus. Now, the first term is going to go into the first terms of your binomials. We're going to break those down into that. And then the second term here, the 40, we're going to break down into factors of that, and they're going to go in the last part of the binomials. Well, you may ask, what happens to the middle term? Well, the middle term is going to come about from this O and I of FOIL. Okay, well, that's where we're going to check. All right, so here's kind of the schema. We're going to split up this x squared. So basically, the only way to split that up is an x and an x. And again, if it's in the front, it's got to go in the front 2 terms of your binomial. Now, we have a nice little trick that we can do here with this power of 1. we're going to need factors of 40. Now, factors of 40 are like 1 and 40, 2 and 20, 3 won't go in, but 4 times 10, 5 will go in, 8 times 6, 7. Those are only factors. So we want to kind of group and figure out some of these things to make this work. So here's the trick that I want you to use. When you have a coefficient of 1 in the front, it's very nice that you can ask yourself this question. What do I multiply to get 40 that I add to get this middle term? What do I multiply to get 40? So which of these factors can I multiply to get 40 that when I add them gives me 13? Well, if I start here, I add these two, I get 41. That's not them. Add these two, I get 22. That's not them. Add these, I get 14. That's closer, but it's not 13. And ding, 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 when I add these two, I do get 13. So I'm going to put a 5 in one and an 8 in the other. Now, why is that good? Because if I break these up correctly, I've taken care of the F and the L of FOIL. First, multiply x times x. That gives me x squared. Outside gives me an 8x. Inside is a 5x. So that put together gives me the 13. And my last term here gives me the 40. So now that I've written it all up and scribbled all over it, those two answers, x plus 5 times and x plus 8, are going to be my answer. All right, let's try this next one. Again, 3 terms. Nothing in common. I'm going to break it down into 2 binomials. I'm going to look at the last sign. It is a plus that matches the first, so they are the same that match the first according to our signs. I'm going to take this first term and I'm going to split it up evenly as an x and an x. And now the work begins, really. Ask yourself, what do you multiply to get 15 that you add to get 8? Well, there's only a couple possibilities for 15, 1 and 15, and 3 and 5. And when you add 3 and 5, you do get 8. So put a 3 in one, a 5 in the other, and those are going to be your 2 factors that are needed. All right, let's do one more of these. Again, if you want to pause this at any time and try them and see if you get the right answer, that might be helpful. All right, so the last one here, again, we have a 1 in front, so we can do our little trick, but let's look at our signs. I have signs that are the same that match the first, so this time they're going to both be minuses. I'm going to go to the front term and split it up evenly as x and x. Whoops. Okay, x and x. And now, again, I have a 1 in front. I can ask myself, what do I multiply to get 45 that I add to get 14? What do I multiply to get 45 that I add to get 14? I'm really hoping you're telling me 9 times 5. If you did, you are correct. Again, I can put a 5 here and a 9 here. It doesn't matter the order, just as long as you have both of them. Okay? All right, very good. Let's try this guy. Okay? Let's see. It's a little bit different because now if I look at my last sign, it is going to be a minus this time as opposed to the pluses that we've seen previously. And so now I'm looking at what do I have for my signs and sign. The last sign is a minus, so they are different according to our rules up here. And I just realized I can't spell different. So change that. Sorry. Different. How's that? That's better. All right, so last sign is a minus, so they have to be different. So I'm going to put a plus here and a minus there. Again, doesn't matter which one that you do and where. I'm going to split this x squared up as an x and an x. And now, since there's a 1 in front, we can use our trick. What do we multiply to get 14 that we subtract to get 5? What do we multiply to get 14 that we subtract to get 5? Well, I'm hoping you look at the factors of 14 as 1 and 14 and 7 and 2. This subtracts to get 13, so that's not it. That subtracts to get 5. So I have to use the 7 times the 2. Now, these ones are a little bit more trickier because to check your outside and inside to make sure I get the middle term, now I really have to focus in on the sign of that number. So I need a -5. So when I do, if I put 7 here and 2 here. Notice that the outside is minus 7, the inside is a plus 2, so that gives me the negative 5 that I need. Negative 7x plus 2x gives me that negative 5x. So these are my 2 correct factors that I need for that problem. Okay? If you were to put the 7 here and the 2 here, you would have gotten a positive 5. So you would need to switch the signs if you get that same number but wrong sign. Okay? So be very careful when you put it in and check the outside inside. So let's try this guy here. 3 terms, nothing in common to take out, so I know it's going to be 2 binomials that I must do my trial and error on. Notice here I do have the last sign is a minus, so the signs are different. I'm going to put a plus and a minus. Then I'm going to split up my x squared as an x, and now I get to ask myself, what do I multiply to get 5 that I subtract to get 4? The only factors of 5 are 1 and 5, but I need a negative 4. So do I need a minus 5 plus 1 or a plus 5 minus 1 to get the negative 4? And I'm hoping you choose the first one. It needs to be a minus 5 plus 1 in order for the outside and inside to equal that negative 4x. So what's going on with my pen here? All right. Okay. All right, let's try this last one again. You may want to try to pause it and see if you can do this one and come back and see if you get the right answer. Last sign is a minus, so they are different inside. I normally just put plus minus. Split up our x squared, so we get an x and an x. And what do we multiply to get 21 that we subtract to get 4? Well, the common factors for 21 are 7 times 3. When I subtract them, I do get 4. But this time we need a positive 4. So I need the larger number with that same sign to make the plus 7x for the inside minus the 3x for the outside to give me that plus 4x for the middle. So remember, the outside and inside are the only things that are going to be used to get the middle term. The 7 and 3 come from splitting up the 21 properly, and the x and x come from splitting up your x squared properly. So that is it for those type of trinomials. Now, not all of the time will you have that nice 1 in front that you can do that trick. But don't panic, because this time we're still going to do some trial and error stuff. This is where you really want to make sure you have a pencil, because it may not work the first time, okay? Lastly, we will be looking at trinomials, which have a coefficient other than 1 in the front. So make sure that we always check the outside and the inside of FOIL in order to determine that you have the correct factors, okay? So the idea with trinomials is still the same. You're still going to factor it down to 2 binomials, but it's not going to be as easy as the last time, okay? The signs still are the same. If the last sign is a minus, they are different inside, so I'm going to put a plus here and a minus here. I need to split up the first term to go in the first 2 and the last term to go in the last 2. So I'm going to start with 7 because 7 is pretty easy. Because 7 is a prime number. The only factors of 7 have to be 7 and 1. 6 is a little different on the front side because I can actually do 1 times 6 and 2 times 3, okay? Now, I will tell you that I normally will start with these 2 factors that are closer together than the other ones as well. So I'm just going to, out of the blue, throw in some factors. Now, with that x squared, I know that I need an x and an x, but this time I need a 2x and a 3x to get my 6x squared. So I'm just going to put a 2x here and a 3x here. Now, the key thing is you got to check the outside and inside, because I'm just trial and erroring here, okay? This times this gives me what I need, and the last term, gives me the negative 7. But I need to check this outside and inside to determine if I get the plus 19. So 2x times negative 7 is negative 14x. Then inside gives me a positive 1 times a positive 3 is a plus 3x. If I put these 2 together, does that give me a plus 19? The answer is no. Okay, so this is where we need to use our eraser. I'm going to come in here and I'm going to erase these factors. Now, you don't want to erase all of them. You just want to erase one set of them because You don't want to do too much here and not get the right ones. All right, so let's try. If this was 2x and that was 3x over here, then this. Okay. Then we want to switch those. So let's try 3x here and 2x here. Let's see if that works. Okay, again, use your pencil. You want to check the outside and the inside. Now, outside, 3x times a negative 7 is negative 21x. Inside is a plus 2x. Oh, that's looking even better. That gives me a negative 19x, which is not exactly what I need because I need a positive 19x, but I do have the number 19, and that's very beneficial because if you have the number but the wrong sign, then we can fix this ever so nicely by switching the sign. So if I make this now a plus, I'm just going to scribble this out and make this a minus. Therefore, I now have it, okay? Outside is a plus 21, inside is a minus 2x. Therefore, I end up with my positive 19. So that's a good trick to happen. If you end up having the same number but wrong sign, just switch the signs. So 3x minus 1 times 2x plus 7 would be our final answer. All right, let's try this guy. 3 terms, nothing in common, so I can't pull any out of GCF, but I can do my trial and error on these factors. Look at the last sign. It is a positive, so they are the same that match the first. So let's throw in a minus and a minus. Let's break apart that 9x squared. So it's either 1 times 9 or 3 times 3. So I'm going to choose to split it as 3x and 3x. Again, I'm just choosing some out of the blue. I don't know if they're right yet or not. For factors of 4, I can choose 1 times 4 or 2 times 2. Again, I like to choose the ones that are closer together. So I always try the 2 times 2 here. And now I get to check the outside and inside term. Outside here, 3x times negative 2 is a minus 6x. Inside, negative 2 times a 3x is a minus 6x. Oh, goodness, looky there. When I put those together, I get my negative 12x, which is exactly what I have right here. Therefore, these are my 2 factors. Those are my answers. Now, hopefully you look at those and you say, well, goodness, they're exactly the same. So actually, I would also accept this as a final answer for a problem like this as well. If you wanted to write it with a power of 2, you are most definitely capable of doing that. Okay? Now, that's what we sometimes call a perfect squared trinomial, but you don't really need to know the name, just know how to factor it. All right, very good. Looks like we got 3 problems to go. We can do this. All right, so another trinomial, no terms in common. 17 kind of throws out that idea. So we're going to have 2 binomials. The last sign is a plus, so they are the same that match the first. And I'm going to have to break down 3x squared and 12, okay? So I'm looking at 6x squared. If I look at 6x squared, again, I'm going to start with like a 3x and a 2x, just picking them out of the blue. I'm not sure if that's the ones that I want. 12 has a little bit more. 1 times 12, 2 times 6, and 3 times 4. Okay, now let me talk to you a little bit here. If I choose to put 3 and 4 in there, okay, just plop them in wherever I want. If I put a 3 here and a 4 here, okay, notice that if I look at this binomial, there's a 3 in common. Well, since the original trinomial didn't have any terms in common, this is impossible. You can't have anything that's in common. Notice here, there's a 2 in common. This is impossible, so no need to even try it, because it's never going to work. So let me undo those out of there. Okay, so if I try to put maybe the reverse of that, what if I were to try to put a 4 here and a 3 here? Now there's no number in common, no number in common. That's okay. We need to check to make sure it works though. Outside here and inside, let's see if that works. So this gives me a negative 9x, and the inside piece there gives me a negative 8x. Oh, that looks very nice. That gives me a negative 17x, which is what I needed. Therefore, this is our answer. Again, use your pencil because you'll end up making mistakes and having to erase on your trial and error. And that's okay. That's the best and easiest way that we can factor these down. All right, let's move on along. Here's just a summary of the way that you need to kind of work through some of these things. First thing always, is there any common terms? And then it's split by whether you have 2, 3, or 4 terms. So make sure that you look at that. And we're going to do a couple here that might have some things in common that can go further a little bit if we need to. So notice here I have 2 terms, but again, are there things that are in common between 5 and 45? 5 will go into each one of those. Between x and x cubed, each of them have at least one x. So when I take that out, what is left over? So 5x times what gives me 5x cubed? Well, I pull the 5 out, I need 2 more x's, minus 5x times what is 45x? Hopefully you're telling and screaming at me that it is a 9. And the question would be, can I go further? Inside here with this x squared minus 9, that's a difference. Is it a difference of squares? Is it a difference of cubes? Or am I done? It may not break down. If this is a plus here, you're done. It won't break down. But since this is a minus, it is definitely a difference of squares. So I'm going to rewrite the 5x. And if you need to remember the difference of squares, that is that a squared minus b squared is a plus b times a minus b. They're exactly the same, except one's a plus and one's a minus. Split this baby up to be exactly the same as x and x. Then you end up having this 9. What do you square to get a 9? It is a 3 and a 3. Powers of 1 on each of these, we are completely factored as far as we can go. Okay, so always check to make sure you can't go further. All right, last one. Notice there's a 6x squared minus 6x minus 12. No x's in common this time because this didn't have any x's, but each of those have a factor of 6. So when I take that out, let's see what's left over. 6 times what is x squared? Oh, there's 6x squared. It should be just an x squared. 6 times what is a 6x? Whoops, should be just a minus x. Okay. And then 6 times what is a negative 12? Well, I need a minus 2. Again, inside here, I need to really decide, can I go further? Well, 1, 2, 3 terms this time. If it's 3 terms, it'll go down to 2 binomials possibly. Again, this may not work. If you check all the factors, you may have a prime polynomial, and that's okay. So, last sign is a minus, so they are different inside. I'm going to split up my x squared as an x and an x. And what are my factors of 2 that when I subtract, I get a 1? Because I have a 1 in front here, we can do that. What do I multiply to get 2 that I subtract to get 1? Well, the only factors of 2, since it's our only even prime number, are 2 and 1. But I need a minus 1. So I need a minus 2 plus 1 gives me the negative 1. So again, the outside becomes a negative 2x. Inside is a plus x. Therefore, it gives me a minus 1x for my middle term. And that checks out for my trial and error. Okay? So that is actually all of our sections in the chapter P that we're looking at. And so these hopefully are some review things. It might have been a while since you've done them, but definitely on this last section with factoring polynomials, you definitely want to make sure that you master that so that we can do other things that involve that as well. So until next time.